sixth FRQ from the 2003 AB exam. So first, they ask us if the function is continuous at x equals 3. There are 3 parts to the definition of continuity, so we just have to walk through all 3 of them. So first, the function has to be defined at that value, and you can see that with the 2 pieces that 3 is allowed to be plugged into the first one. So I'm going to say f of 3 is the square root of 3 plus 1, which is 2. So f of 3 is defined. The second part of the definition of continuity is that the limit has to exist. That means that the left-hand limit and the right-hand limit have to equal each other. So I'm going to say the limit as x approaches 3 from the left. And you can say of f of x if you want. You can write the square root. I already got that that was 2. The limit as x goes to 3 from the right would be 5 minus x. So that's 5 minus 3, which is also 2. Therefore, I'm going to say that the limit as x approaches 3 of f of x exists. And then the third part of the definition says that whatever you get when you plug in 3 is the same as the limit. So f of 3 equals the limit as x approaches 3 of f of x. And so now we can conclude f is continuous at x equals 3. Okay. Part B is not part of Unit 1. Finding the average value, but I liked questions A and C, so we'll go ahead and leave it. So the average value on the closed interval, we have to do 1 divided by b minus a, and then find the integral from a to b of f of x. So we're going to say 1 over 5 minus 0, and then the integral from 0 to 5 of f of x dx. Now this we do have to split up because that interval is based on 2 different functions, and so, well, 1 function but 2 different pieces. So I'm going to say 1/5, and then I'll say from 0 to 3 plus 3 to 5. Okay, so for the first part, you could do this using U substitution, but you don't really need to because the derivative of the inside is just 1. So I'm just going to go ahead and say this is x plus 1 to the 3/2 divided by 3/2. And then I've got 5x minus 1/2 x squared. I'll go ahead and just start plugging it in. 3 plus 1 to the 3/2 minus 0 plus 1 to the 3/2. And goodness gracious, I would probably leave it there, to be honest, because that's a whole lot. But if you want to keep simplifying so you can get it down, we've got 4. So the square root of 4 is 2. 0 plus 1, anything multiplied by 1 is itself. Okay, so we've got 2 to the 3rd is 8. 8 times 2, we got 16/3 minus 2/3. 25 minus 15 is 10. Negative 25 halves plus 9 halves is negative 16 halves. 10 minus 8 is 2. So that's 14 thirds plus 6 thirds. But again, I would not do that. I would leave that right up here. There's no reason to. Okay, part C wants you to say that you've got g of x, you know that g of x is differentiable. That means that if it is differentiable, that means that this has to be continuous, which means that 3 is important, and that when you take the derivative, that it's still continuous at 3, so that you can have that differentiation. So we've got g of x is k times the square root of x plus 1 over mx plus 2. So if we plug in 3, it should be continuous. So we've got 2k equals 3m plus 2. I can't do anything with that yet, but it's going to be important in a second. When I find the derivative, I'm going to have k times, I'm going to think of this as x plus 1 to the 1/2. I've got 1/2 times x plus 1 to the negative 1/2 multiplied, I'm doing the chain rule, multiplied by the derivative of the inside, which is 1. And then for the second piece, derivative of mx is just m. The plus 2 would not have, it would have a derivative of 0, so I'm not even going to write it. And then here I need to plug in 3 as well. So I've got k over 2 square root of 3 plus 1. Okay, so these are the two equations that I'm working with, and now we're having a flashback to Math 1, and we're just solving this with substitution. So I have 2 times k equals 3m plus 2. And then after I have the m, I can go ahead and plug the m in to find the k. So k equals 4 times m. There we go.